So you know how to shorten the if function. We learned about this if. Do you still remember? This one will check whether any input, which is number, divided by 2 and the remainder is 0. If the remainder is 0 means the number can be divided by 2. So if it is true, then it is even. If it is not true, then even is false. So this kind of code can be converted like this one. Even equals to, this is a Boolean statement. So number divided by 2 equals 0. So this is modulus to check what is the remainder when this number is divided by 2. Okay, we learn this one in the Python. So if you input any number, and then I would like to check whether it is even or not. So even equals to number divided by 2. So divided means this is the remainder or modulus. If the number can be divided by 2, or we can say the number remainder 2 equals 0. If it is true, then we will print even. If it is false, then we will print false. Okay. You run this, then you will see if I enter 5, then we will print out, and the variable event is false. Okay. If I run again, let's say I put 8, then it will show it is even, and variable event is true. Now there's another problem. So the body mass index, if you still remember, we learned this one last week. So we want to know the BMI or body mass index by measuring the health on weight. You know, we already have the kind of calculator. We can calculate from the weight and the height from somebody into a kind of numbers. So we want to take again this input, the weight and the height, but let's say, now I'm going to get the input using the kilogram, weight in kilogram, and dividing by the square of the height in meters. So the formula will be this one. Weight in kilogram divided by the height in meters, and then we want to square this one. Square means, let's say I have a variable x, so I can just multiply again with x. So x multiplied by x is square. Okay. Or we can have the x star 2. Okay. So it is square. And whenever I get a value, so I would like to put the category. Let's say the BMI is below 18.5, then the person is underweight. If the BMI is in between 18.5 until 24.9, then the BMI is normal. If in between this number, overweight, and if above 30, then obese. Now, how can we make the if? I give the solution. Okay, I will just copy and paste this one. I will make a new Python file, BMI sample, and then I just paste. Before the first, I'm just using the code that we already learned last week. Okay. So let's say I'm going to get the input using the pound. So weight, let's say the weight is in pound. And the height, let's say the height is in inches. So yeah, the total will be in inches. I think you already know we can convert from pound to kilogram, and then we can calculate from inch to meter. So the weight will be, weight in kilogram will be this one, weight multiplied by kilogram per pound, and then height in meters will be height multiplied by meter per inch, and then the MI is the weight in kilogram divided by height in meters multiplied height in meters. And I want to put the parenthesis. Why? Because I would like to do the square on this one first, and then let the weight be divided by this number. So it is good practice to put the parenthesis. Now, I would like to display the result. So the BMI is, okay, we have format. What does it mean by format? Let me just show you like this one. I would like to print BMI. Okay. So if BMI is less than 18.5, print underweight. If, so this is another condition. If BMI is less than 25, then normal. If BMI less than 30, overweight. Else, obese. Okay, now let's see. Weight in pound. Let's say I put 140. Height in inches. I'm not that good in inches, but let's say 150 inches. So there is an error. If you have this error, line 12, okay, you can see line 12. We have this error, matter oh. Do you know what is this error? this is not correct. Okay, because we want to multiply, this should be multiplied. Okay, I'm mistyping this one. So let me run again. Enter the weight in pound 140, and then the weight in inches 150. Okay, the BMI is 4.37 something underweight. Okay. Maybe it's too small for the inches. Let's say I will keep 140 pound, and then the height, let's say I put 350. Okay, so you can see like this one. Let's say I do not want to use the pound and inches. I want to use kilogram and meter. And what should I do? So let me create a new Python file. BMI example 02. So just let me copy and paste this one. So I can change, enter the weight in kilogram, and then enter the height in meter. So I don't need this one. I can just delete this one. So just change this weight in kilogram and then change this one to height in meters. And in finish, we don't need to convert from the pound. We don't need to convert from the inches. Now let's see if I run this. Enter the weight in kilogram. Okay, let's say I am 90. Enter the height in meters. Let's say 180. Oh, okay. It is underweight. You can see here 0.0027777 is too long. Okay. Usually we will not consider the last digit, right, because it is too long. And we want to make it a good format. So I'm going to use this format PMI, and then I would like to just use two numbers after the comma. So let's say weight is 90, and then the height is okay, 2 meters. So you can see the number here is 22.50. So it is exactly just two numbers after the comma. You can run again. Let's say 90 kilo, and then I have 1.8. So actually the number is very long, but we want to keep only two numbers after the comma. So this is the way. We want to put the dot and then 2. It means two numbers after the comma, and the number will be in the float type. So we need to put it into the format like this. Okay. So in Python, there are some logical operators. Now we call this is the Boolean operators. There are three logical operators. First is not, which is negation, and which is conjunction, and OR, which is disjunction. Now let's see one by one about not. What does it mean by not? Not, it is just the opposite. So if I have P, let's suppose this is a kind of condition. And if the condition P is true, so if I put not P, then it will be the opposite. It becomes false. If the P is false, so I'm going to put the opposite, of course, which is true. So if I have X is higher than 80, yeah, let's assume X is 24. 24 higher than 18, it is true. But because we put not, then it becomes false. Gender, let's suppose gender equals to M. Gender equals to M. This one is false. But we have not, then it becomes true. Let me just show you. Let's say I have H equal to 24, and then if not H less than 80, oh, H is greater than equal to 80. Print you are higher than 80. Sorry, you are not higher than 80. So if you run, nothing happens. Why? We are going to execute this if the condition is true, but this condition is false. Why it becomes false? Because we have not. It's higher than equal to 80. This is true. Because we have put not, then it becomes false. So you can check. Print not it's higher than 80. Then you can see that the result of the condition is false. Okay, the same with this one. So if you want to consider the okay, this is okay, then let's say if I have gender equals to F. So I want to check whether not gender equals M. Gender is equal to F or female. So I'm going to check whether the gender not equal to M. Gender equals to M is false. So we put not, then it is true. Next, we have another operator, we call it the conjunction or AND. If the P is false and the P2 is false, so P1 and P2 becomes false. If the P1 is false and the P2 is true, then P1 and P2 is false. If P1 is true and P2 is false, then P1 and P2 is false. P1 and P2 is true, then both of them will be true. Okay, so this is the mathematical operation. Usually we do not use false and true, we use zero. Like 0 and 0, the result is 0. 0 and 1, the result is 0. 1 and 0, the result is 0. 1 and 1, the result is 1. Now I'm going to check. Let's assume x equal to 24 and gender is f. X is higher than 18 and, okay, so usually we put the parenthesis like this and we put the operator and gender equals to f. X equal to 18, it is true. The H is 24, so 24 is higher than 18. Gender is F, yes, it is true. And the operator is N, so true and true. The result is true. What about this one? H is higher than 18. Because H is 24, then it is true. Gender not equal F. This is not equal. Not equal F means, yeah, because we know that gender is F. If not equals F, then it is false. The condition P1, this is P1 is true, and the P2 is false. Then, because we use the operator and, the result is false. We have another operator. We call it OR operator. This junction, this is OR. OR has different context with the AND. If P1 is false and P2 is false, P1 or P2 is false. So it's 0, 0, then 0. If this one false, 0, and this one true, so the result is true. If this one true and this one false, the result is true. If it's true and it's true, the result is true. So at least there is one true, then it will be true. It's different with the previous one. If one is false, then it becomes false. So let's see. If I have again the gender is F and H is 34. H is higher than 34. 34 is higher than 34. This is false. Gender is F. This is true. The operator is OR. Then we have false or true, then the result is true. What about this? Oh, I think this one should be OR. Sorry, this is OR. Sorry, this one is OR. X is higher than 34 because X is 24, then it is false. Gender equals to male. Gender is F, female. Then this is also false. False or false, it means false, and this one is also false. With the operator OR, the result will be false. Okay. So you can have the combination. Okay. Let's say I have A is 6, B is 7, and C is 42. You know, if A equals to 6, yeah, this is true. If A equals to 7, this is false because originally A is 6. A is 6 and B is 7. The result is true. A and 6, it is true. B and 7, so this is true. A and 7, A equals to 7, false. B equals to 7, true. So false and true become false. Not A equals to 7. It becomes true. And B equals to 7. True. So the result is true. A equals to 7. False. Or B equals to 7. Okay, this one false. This is true. So the result is true. A equals to 7. False. Or B equals to 7. B equals to 6. False. Both of them are false, then the result is false. Now, we have the parenthesis. A equals to 7, false. And B equals to 6, false. So both of them are false. Then the result is false. We have not. It means we want to check the opposite. So it becomes true. Not A equals to 7. A equals to 6. So it is true. And B equals to 6. False. And the result is false. Okay. So let's try with this code. Let's try to understand what does it mean by this code. In the first line, I will receive an input. Okay, this input, let's suppose the input is integer. So I will put it into the variable number. And then here is the first check. If the number can be divided by 2 and if the number can be divided by 3, so number is divisible by 2 and 3. Okay. And it means if the condition, both condition is true, so we will print this. If number divided by 2 or number divided by 3 equals to 0, or the remaining is 0, then the number is divisible by 2 or 3. So if one of them is false, then we can say just false. The other kind of condition is if number remainder 2 is 0 or number remainder 3 is 0 and not number remainder 2 equals to 0 and number remainder 3 equal to 0, then the number is divisible by 2 or 3 but not 4. Okay, let's see. Let's put the number. I would like to enter an integer 4. 4 is divisible by 2 or 3. And 4 is divisible by 2 or 3, but not good. Now I will check if I put 6. What happened? The result will be 6 is divisible by 2 and 3. And 6 is divisible by 2 or 3. Because two conditions are true. Okay. So what does it mean? This will happen if the number cannot be divided by 2 and 3 at the same time. So those two will be executed whenever the number can be divided by 2 and 3. Okay, so 6, it can be divided by 2 and 3, so it will be also executed because both conditions are true. But this one, it will not be executed because both number cannot be divided by 2 or 3. Okay, so in this case, if I put 8, then of course this number cannot be divided by 3. Then the result will be 8 is divisible by 2 or 3, and 8 is divisible by 2 or 3, but not 4. Okay. Question. What is the result? Suppose x equals to 4 and y equals to 5. X equals to 4. 4 is higher than equals to 5. 5 higher than equals to 0. What is the result? False? True? 4 is higher than y. It's true. 5 is higher than 0. It's true. Okay, so you can try. Let's have x equals to 4 and y equals to 5. False. True and false. Why? When we have 4 higher than equals to 5, it is true. 5 higher than equals to 0, it is true. But why it is false? Let's see this one. 4 less than equals to, sorry, 4 higher than 5, this is false, this is true. X 4 less than equals to y, true. Y higher than equals to 0, is true. X not equal to y, this is true. Y equals to 0, false. So this condition is false. Okay. Because 4 is not equal, 4 is not higher or equal to 5, and this one is true. Y is higher than equals to 0. So it is like the sequence from the left to the right. We will check this one false and this is true. So we just say this is false. What about this? X is less than equal to 4. Sorry, 4 is less than equal to 5. This is true. And Y is higher equal to 0. So it is true. This one, X not equals to Y, 4 not equals to 5. This is true. And Y equals to 0. Y is 5 equals to 0. This is false. Because one of them is false. We consider this is false. But this kind of statement is a little bit strange. People will not use this kind of expression because it is a bit complicated. So there's another problem. Determining the leap year. Do you know leap year? I've got the Korean. Leap year. Yun. Okay. So how to calculate the leap year? So the basic idea of the leap year is a year is a leap year if it is divisible by 4. So if the year can be divided by 4, but not by 100, or it is divisible by 400. Okay. So the formula will be like this one. The year can be divided by 4, but not by 100. So when the year remainder 100, it is not you. Or, because we have or, so we put or, year remainder 400 is 0 because the year is divisible by 400. So we can just put this formula. First, let's input the year. And then I'm going to make a new variable is leap year. So I'm just putting this formula. If year is divisible by 4 and year is not divisible by 100, or year is divisible by 400. So enter a year. Let's say 2000. Okay, 2000 is a leap year. It can be divided by 4 and it can be divided by 400. Now let's have 2004. Okay, 2004 is a leap year. Yes. Let's say I have another 2002. So 2002 is not a leap year. Okay, so this is the way to get the leap year. That is another problem. It's about lottery. Write a program that randomly generates a lottery with two-digit number. Do you know lottery? Like lotto. Okay. So I want to get two-digit numbers, random. Two-digit means yeah, 9 or yeah, 6 2 or something. Okay. And prompt the user to enter two-digit numbers. So the lottery, the lotto, yeah, they will generate random, and I need to guess what is the number. And that means whether the user wins according to the following rule. So let's say if we have the random number is 23, if the lottery number is 23, and then let's say the user guessed 23. So it means the user matches the lottery in exact order. So exactly the same, 23 and 23. Then the award is 10,000 US dollar. But if the user input matches the lottery in any order, for example, the lottery number is 32, but user guess 22. Okay, then the award is 3,000 US dollar. If one digit in the user input matches a digit in the lottery, then the award is 1,000. It means if the lottery number is 37, so my guess is 23, then okay, 3, this is available. So the award is 1,000. How can we make the code? So let me just give you the code here. Lottery. So the first, I would like to make a random number. Okay. So I keep it as a comment. So later you can do. You can just open it to make it as a random number. Now let's assume that I have just a number. Lottery is 23. The number guess is a variable from the user input. And then what I will do is check the digit. How to check the digit? If I have 23, then how can I get the first digit? 23 divided by 10. What is it? Then the integer result is 2. Okay, so this 2 will be the digit number 1. And then remainder 10. Then we will get the last digit. The last digit will be the digit number 2. Okay, so that's the meaning by digit number 1 and digit number 2. And then after that, I have the guess digit 1, the guess digit 2. So you can make the if. If the guess equals to the lottery, then exact match. But we have another option. If the digit 2 equals to the digit 1 and the digit 1 of the guess equals to the lottery digit 2, then this is the one. Or we have this option. If at least one of the digit matches, then you will 1,000. If not, sorry, no matches. So if I pick two digits, let's say 3, 4. Okay, I win 1,000 because, yeah, I assume this lottery is 23. So 3 is maths. So I will just win 1,000. Again, if I put 23, okay, this is maths. So I got 10,000. Okay. Yeah, I think it's the time. So I will stop.